Hello students, so welcome to my next online class. So here I am with a new chapter, that is chapter number 4, work and energy. Okay, so you see, work is said to be done when you apply a force on any object and that object moves a small distance or there is a small displacement. Then only we can say a work is said, means work is being done there, right? So there are many activities in our day-to-day life. We feel we are doing work, but actually we are not. Okay, so in physics we say that we are not doing any work. So let's see what are those activities, like pushing a wall. So that means whenever you are pushing a wall, you are applying a force on the wall, but the wall does not move, so there is no displacement of the wall. Okay, so you are applying a force on the wall, but wall is not moving, so we say that work is zero there, means we have not done any work. Okay, similarly, holding a heavy object, suppose a big block or a big stone you are holding, just you are holding up, but as you are holding you will be tired of holding, so after some time you have to keep, so you will lose your energy. Okay, but in physics it said that you have done no work because you are not moving with that object. Okay, so you have to apply force as well as there should be a displacement. So these are the two conditions. Next you see reading a book. So though reading a book will create a mental pressure, so whole day you are sitting in one place and just you are studying, you are just going through the book, so according to you, you feel that you are getting tired, right? So but in physics it said that you have done no work again. Why? Because there is no displacement. So work is said to be done when a force is applied on an object and that object starts moving or makes a little bit displacement. Okay, there is a little distance it moves, then only we say that work is said to be done. So let's see what is the definition here. Work is said to be done when a force applied on an object causes its object to move through a distance in the direction of the force. Like if I push a, let us consider this is a big block. So when I am applying a force on this object, the object is moving in same direction in which I am applying force. So I am applying force in the right hand side, so the object is also moving in the right hand side. So we say that there is an work done. Okay, so work, now you see there is also nature of work. Like when I say, when I am pushing a wall, when I am reading a book, when I am just holding a heavy object, no work is said to be done. That means in that case work is zero. Similarly, when you are pushing any object, an object is moving in the same direction of force, in which direction you are applying force, the object is moving in same direction, then we say that is a positive work done. Okay, next we have negative work done also. Like for example, you have thrown an object up. Okay, when you throw an object up, you see gravity, the force of gravitation acts vertically in downward direction. That means our earth is pulling everything which we throw up, right? So gravitational force is acting in one direction and the displacement is in upward direction. Okay, so where the object is moving to a maximum height. So when it goes in a maximum height, the gravitational pull is in opposite direction. So in that case we say that work is said to be negative. So what we have come to know here, work can be zero, work can be positive, work can be negative. When there is no displacement or no force, that means work is said to be zero. When you are applying force and the displacement in the same direction, then that is positive work done. When you are applying force but the displacement is in opposite direction, that means you are applying force in one direction, displacement is taking place in other direction, that is also negative work done. Okay, so that means when we are walking, when we are running, we say that we are doing work. Okay, so let's see in which cases we are doing work actually, that is climbing stairs, picking up an object from the ground. So when you are picking up an object from the ground, that also said to be as done work done. Walking and running, stretching a rubber band, that means when you are stretching a rubber band, so you are actually doing work there. Okay, squeezing a ball. So these are all the activities where we are doing work, but whereas these are the activities where we are not doing work. So in a simple sense, what is work done? That means work done equals to force into distance or displacement. Okay, displacement, force or displacement. That means work done, the amount of work done depends upon two factors: how much force you are applying or how much distance it has moved. So by this we can calculate the work done. Now when I say work done, force is in Newton, 1 Newton, and distance or displacement in 1 meter, that means 1 Newton meter, or this is also said to be as 1 joule. Okay, so if I ask when a work is said to be as 1 joule, work is said to be as 1 joule when 1 Newton of force is applied on an object and object moves through distance of 1 meter. I repeat, when a 1 Newton of force is applied on an object and that object is moving through a distance of 1 meter, that time we say that 1 Newton meter, and 1 Newton meter equals to 1 joule. Okay, so these are the definitions you have to remember. You can follow the books. You will be writing these notes in your exercise book. Okay, you will pause your video and you will note down. So the next subtopic we have energy. So you see, work and energy both are related to each other. So that means if you don't have any energy, you will be unable to do any work. That means to do any work, energy is required. So how can you define energy? The capacity or an ability to do work is said to be as energy. So that means if you are capable of doing any work, that means you have energy. If you are not capable of doing any work, then we say that you have low energy or you don't have any energy, right? So SI unit of energy is what? Joule. So energy is defined as the capacity or ability to do work. So whenever work is done, there is always a change or transfer of energy. So that means whenever you are doing any work, your energy level gets decreased, right? So we get tired. So why we get tired? We get tired when we do some work, right? So therefore energy and work both are related to each other. Okay, now there are some conversion among the units. You see, higher unit, smaller units, like you see SI unit of energy is joule, but 1000 joule is said to be as 1 kJ, that means 1 kilojoule. Similarly 1000 kJ, that means 1000 kilojoule equals to 10 to the power 6 joule, because kilo means 1000, 3 zeros, so 3 plus 3 6, that's 10 to the power 6 joule, and 10 to the power 6 joule equals to 1 megajoule. Okay, so this is the conversion. Similarly 1000 megajoule equals to, now mega means what? 6, so 6 plus 3 9, that's why 10 to the power 9 joule, and 10 to the power 9 joule equals to 1 gigajoule. So these are the conversions. Okay, now you see, energy, when I say, there are two types of energies, like mechanical energies. So mechanical energy means kinetic energy and potential energy. Whenever any object is moving or it is in motion, the energy possessed by that object is said to be as kinetic energy. Similarly, if an object is at rest or a certain height, so the energy possessed by that object is said to be as potential energy. So how can we define kinetic energy? So kinetic energy can be defined as the energy possessed by a body by virtue of its motion. The energy possessed by a body by virtue of its motion is said to be as kinetic energy. The energy possessed by a body by virtue of its rest or position is said to be as potential energy. Virtue, when I say virtue, Virtue, okay, virtue. The energy possessed by a body by virtue of its motion is said to be kinetic energy. The energy possessed by a body due to in a state of rest is said to be as potential energy. So this is how we differentiate potential energy and kinetic energy. And potential energy and kinetic energy together, they are known as mechanical energy. Okay. So kinetic energy, when I say the energy possessed by a body due to its motion, okay, so that is kinetic energy, and kinetic energy has one formula. Kinetic energy equals to half mv square. This is the formula of kinetic energy. That means kinetic energy depends upon how many factors? It depends upon mass and it depends upon velocity. M stands for mass and V stands for velocity. More will be the mass, more will be the kinetic energy, more will be the velocity, more is the kinetic energy. That means if two bicycles are there, let us consider. Two bicycles are there and two boys riding that bicycle. One is riding very fast than the other. Then we say the boy who is ahead, who is running very fast or riding the paddling that bicycle very fast, has more kinetic energy than the boy riding slow. Okay, that means whose velocity is more, its kinetic energy is more. Similarly, whose mass is more, kinetic energy is more. So kinetic energy depends upon mass and velocity. Okay, how it is related? Half mv squared. So this is the formula of kinetic energy. Similarly, potential energy can be of two types again, that is gravitational potential energy and elastic potential energy. Okay, so potential energy means the energy possessed by a body by virtue of its rest or motion, or rest or position. That means the object is still now, object is not moving. So when object is not moving, we say that it is a potential energy. But when an object is moving, we say that energy possessed by that object is a kinetic energy. Okay, so potential energy are also two types: gravitational potential energy and elastic potential energy. So let's see what is gravitational. Suppose this is a building, right? So from the ground floor you have taken a block through the stairs and you have placed up. Now the block is here. Initially the block was in the ground. So when you have taken that object on the top of the building through the stairs, so the energy possessed by the block on the top of the building is said to be as potential energy. Okay, so like for example, you have filled a bucket of water. Now bucket of water you have raised from the ground and you kept at your head. So the energy possessed by the bucket containing water is said to be as potential energy. That means whenever any object is at a certain height, the energy possessed by that object is having a potential energy. That is gravitational potential energy. That means against the gravity you are doing some work. Okay, so against the gravity. So gravity force is acting downward, but you are doing against the gravity. You are taking an object from ground level to higher level. So you are doing some work, you are wasting some energy, and that energy is converting into potential energy. Okay, so that is potential energy. So the gravitational potential energy. Elastic potential energy, suppose a rubber band. Rubber band, you are just stretching a rubber band. So when you are stretching it, so it is having an elastic in nature. So the energy possessed by that rubber band is said to be as elastic potential energy. Okay. So potential energy are of two types, that is gravitational potential energy and elastic potential energy. Kinetic energy depends upon two factors, that is mass and velocity. Similarly, let's see what gravitational potential energy depends upon. Gravitational potential energy depends upon mass, gravity, acceleration due to gravity, and height. So it also depends upon mass. More bigger object you try to displace against the gravity, more potential energy. G means gravity, acceleration due to gravity, and H means height. The more height you take that object, so more will be loss of potential, means more will be the storage of potential energy, or you will be more tired, right? So potential energy depends upon how many factors? Three factors, that is mass, acceleration due to gravity, and height. Kinetic energy depends upon how many factors? Two factors, that is mass and velocity. But what is the formula of kinetic energy? Half mv square, and potential energy mgh. So these are the formulas, and both kinetic energy and potential energy SI unit is joule. So here you see, here there is no work done, an object is just being lifted, a girl is just reading a book, a girl is just pushing a wall, so no work is done here according to physics. But here a girl is climbing out the stairs, a boy is lifting the block of cartoon, a person is just stretching a rubber band, squeezing a ball, you see. So these are the activities where work is said to be done. Okay, so work based upon two factors, that is force, how much force you are applying, and what distance the object has moved. That means work done depends upon two factors, that is force and displacement, or you can say distance. Okay, so SI unit of work is joule, or 1 joule is 1 Newton meter when 1 Newton of force is applied on an object and it moves by 1 meter. Okay, already I have explained you. So you will see these numericals also based upon work done formula, work done force into distance. In the numerical, force and distance is given, just you will multiply and you will get the answer. And at last, do not forget to write joule. Okay, so these are the example numericals. Also we have kinetic energy here. The capacity or ability of doing work is said to be as energy. Energy are two types, one is kinetic energy and potential energy. Both together is said to be as mechanical energy. Okay, when an object is raised to some height above the ground, then potential energy, we said that is a gravitational potential energy. When an object is stressed, you see here it is stressed, bow and arrow. When it is stressed, then here potential energy is said to be done. A girl is running on the road, that means the energy possessed by that girl is having a kinetic energy. Okay, so kinetic energy depends upon two factors, that is mass and velocity, whereas potential energy depends upon three factors. You see here it is given for kinetic energy, two factors. Okay, so you will go through this topic. See, there is a formula, means numerical based upon this formula, half mv square. Directly mass is given, velocity is given, you need to just put in the formula. Gravitational potential energy is also there. Okay, up to here, up to potential energy, you will just go through it from your textbook. Okay, till then, thank you.